Shout out to Sadie. Shout out to Scott. Who else? Who's that? Cole. Cole Kasky. Let's do it. All right, degree measure. How many degrees in a circle? 360. All right. So we use that little symbol up top. We call it a degree symbol. There's 360 of them in a circle. Why do you think they divided a circle up into 360? Maybe 365 days to revolve around the sun. And so they like the number 360 because it was close to that. I don't really know. It's very divisible. 360 is a nice number. It's not always nice to work with in mathematics. We like to work with smaller numbers than 360. So we like to work with a different type of number. For example, radians. 2 pi radians in a circle. The radian measure is the number of radii you can wrap around the arc. I showed you this before. I'll show you again. This red line is a radius. When I've wrapped one of them on the arc, around the circumference, okay, when I wrap one of them, that might be about 1 radius. That gives me a measure of 1 radian. So notice the difference between 1 degree and 1 radian. Pretty significant, isn't it? You could put about 59 degrees in 1 radian. What? Is that actually 1/360th? I just drew a really small spot, right? This is approximately 1 radian. What I did is I drew this length until I had covered about the same amount as a radius. So I look at this length right here, and I kind of draw till I get to that spot. So if I draw another one, we did this the other day, that might be a 2nd radian. I draw another one. In 180 degrees, are there more than 3 radians or less than 3 radians? There's more than 3 radians. You have 1, 2, 3, and then you have this sliver left over. That sliver is exactly 0.14 yada yada radians left over. Because how many radians fit in 180 degrees? Exactly pi. And so if we continue to draw them all the way around, you would see that we would have another sliver left over. That sliver is 0.28 of a radian, because all the way around is 2 pi radians, or 6.28. One, 2, 3.14, 4, 5, 6.28. So there you have them. That's how they define a radian. The number of radiuses you wrap around. Okay? So we could convert back and forth. Don't do that. All right. We can convert back and forth. Degrees to radians. Here's what you do. You take whatever your angle measure is, theta, and you multiply it by pi over 180. Some people don't like it written like that. They would prefer to write it like theta times pi over 180. Those are the same formulas. Yo. Uh-huh. Radians to degrees. We take theta and we multiply it by 180 and we divide it by pi. That's what we'll do. So on Friday you got a quiz. You can't use your calculator. You got to convert degrees to radians, radians to degrees. And we're going to teach you how to do it right now. Every year I teach this, somebody's like, why didn't you teach it differently that time? You know, well, we're just going to do what works best for as many people, and hopefully you can connect with something in between. So, rewrite each angle and radian measure as a multiple of pi. We're going to list them all out, okay? We'll do the first one. 0 degrees. I want to convert 0 degrees to radians. So I take 0, and I multiply it by pi, and I divide it by 180. What is 0 times pi divided by 180? 0. We use a degree symbol to mark degrees. We use nothing to mark radians. I go to 30. Take 30 times pi and divide it by 180. 30 over 180 reduces to what? 1 over 6. So this ends up being pi over 6. So I go up to this spot, call it 30 degrees, or pi over 6. 45 degrees. I take 45 times pi divided by 180. How many times is 45 going to 180? 4. So we get pi over 4. So we've got 60 degrees. Whoop, sorry. Losing my mind. 45 degrees is pi over 4. Booyah. All right. See the conversion? If you go to your calculator and you go 45 divided by 180 and you press math, convert to fraction, it will even put it in its simplest form for you. 1 over 4, just attach a pi, so pi over 4. Okay? I don't use the conversion anymore at this point. If this works for you, great. Last few times I taught this, they said, why didn't you show us how to do this first? So I'm showing you now, okay? Hopefully this works for all of you. My next spot is 60 degrees. I'm not going to use the conversion. I'm just going to think about it, okay? 60 degrees is how many 30s? 2. So I have 2 of the pi over 6's. 2 pi over 6 makes pi over 3. $90 is how many of the 30s? 3. Or 3 pi over 6, which is pi over 2. So now, I've got this first quadrant made. As long as you can remember these values right here, then you can construct the rest of it really easily. Because my next spot is 120 degrees. 120, and I just look for what it's divisible by right away. It's not divisible by 90, but it is divisible by 60. How many 60s go into 120? 2. So you're going to have 2 of the pi over 3's, or 2 pi over 3. $135 degrees. Ooh, we don't like that one. I get it. Well, if you can see, that's at the 45 degree angle spot, isn't it? How many 45 degree angle spots went into that? 1, 2, 3. So it's 3 of these. 3 pi over 4. Then we got 150 degrees. 150 is not divisible by 90, 60, 45, but it is by 30. How many 30s go in 150? 5. So 5 pi over 6. Then I got 180. Well, 90 goes in 180 2 times. I got 2 of the pi over 2's, or pi. Do you see the method of my madness? I mean, I didn't really use the formula. I kind of did, kind of didn't. But I think that that's a nice way to come up with them. I think that people who are able to reference the answers quickly are able to make sense of them based off of these numbers. That's what I think. That's what I hypothesize. Down here gets a little bit more difficult. Instead of thinking as pi, though, I always think of it as 2 pi over 2, or 3 pi over 3, or 4 pi over 4, or 6 pi over 6. Because those are the numbers I've got over here. So I write it as common denominators. This one right here, it's 210 degrees. How far past 180 is that? 30 degrees. Or pi over 6 past 180. Or pi over 6 past 6 pi over 6. 7 pi over 6. Right? 1 pi over 6 past 6 pi over 6 is 7 pi over 6. 225. That's 45 degrees past 180. Or pi over 4 past 4 pi over 4. Which is 9 pi over 4. And then sometimes when I get to numbers like this, I don't even think of that way anymore. Like when I get to 240, I automatically think of 60. How many times is 60 going to 240? 4 times. So I've got 4 of these. So 4 pi over 3. $270. Ooh, divisible by 90. How many 90s go in 270? 3. So I've got 3 of these, or 3 pi over 2. Then I got 3 hundo. How many 60s go into 300? 5. 5 60s, or 5 pi over 3. Oh, 315 is a hard one. I know it's the same location as a 45, so I just count. I got 1, 2, 3, 4, 5, 6. Looks like I got 7 of them. $330. 330. So, 30 goes in 330 how many times? 11. It's going to be 11 of the pi over 6's. 11 pi over 6. And we get back to the very beginning where you have 360 degrees, which is the same as 2 pi. 2 pi. What do you think? Are you ready? You're going to compete. You need to be in groups of 2 or 3. 2 or 3. Quick find a partner and scratch sheet of paper. Go. Alright, so we move along. What's that? Yeah. So you guys know how to do these now, okay? Like 360 degrees we said was 2 pi. 240 degrees you said was 4 pi over 3. But let's do one that's not up on the circle up there. 105, I don't see 105. So you actually have to take 105, multiply it by pi, and divide it by 180. Now 105 and 180 are both divisible by a number. They're both divisible by 5. 105 divided by 5 is 21. 180 divided by 5 is 36. And if you say you don't know what 180 divided by 5 is, then you need to go 5 goes into 180. 3, 15, minus, I get 3, 0, 6, okay. So you're going to have to work it out, okay? That's fine. It's okay if you can't remember that. And then 21 pi over 36, both are divisible by 3. And so 21 divided by 3 is 7, and 36 divided by 3 is 12. So 7 pi over 12, okay? So we divide it up into sixths. We could divide it up into 12ths if you'd prefer and have a quiz on that. But we're just going by pi over 6 each time. Okay. That'll be fine. 7/12 pi would be fine. I will say that, what's used most often is that. So that's fine. Just don't write 14 pi over 24. Okay. All right. Flip it over. Here we go. All right. So the question is, if we are right between a degree, for example, let's say let's say straight ahead is 90, and I point to Emily, and Emily's 92 degrees, and let's say that Holly is 93 degrees, then what would my good friend Taylor be? 92.5, or 92 degrees and how many minutes? See, just like we measure in time, like right now we're somewhere between 46 minutes and 47 minutes on the clock. You would never say to somebody, well, it's 12:47.5, right? You would never say that, right? You'd say it's 12:47 and hold on. 30 seconds. You'd say 12:47 30 seconds. You wouldn't say 12:47.5, right? Same thing with degrees. Okay, when we look at longitudes, latitudes, stuff like that, we like to measure degrees, minutes, seconds. So we should be able to convert back and forth. You don't have to do this on your assignment today, but you will have to use this later on. So we're going to practice it right now real quick. And here's how we do it. This is an example of degrees decimals right here. Degree decimal. And this is an example of degrees minute second. You can see it's listed out each time. So degree decimal, we want to convert that to degrees minute seconds. Then here degrees minute seconds, we want to convert that to degree decimal. We got to convert back and forth. So let's just start here. 80.6 approximately. If it's 80.6, it's going to be 80 degrees and a certain number of minutes. Is it going to be more than 30 minutes or less than 30 minutes? Or, because 0.6 is more than half. To figure it out, you actually take the decimal, you multiply it by 60 minutes. So, I take my calculator, and I take 0.6125 and I multiply it by 60. Whoop, what happened there? Times 0.6125 times 60. I get 36.75. So we just figured out how many minutes. 80 degrees, 36.75 minutes. So I'm somewhere between 36 and 37 minutes. How many seconds is 0.75 minutes? How many seconds is 0.75 minutes? Yeah, 3/4 of a minute is the same as 45 seconds. So now we're going to take the decimal, which is 0.75, and we're going to multiply it by 60 seconds. So that's what we do. 0.75 times 60. And we get 45. So 80 degrees, 36 minutes, and 45 seconds. If there was a decimal at that point, we just write the decimal out. Because like when I time, say Preston in the 100-meter dash, it's like 10.23 seconds, right? Usain Bolt's got to watch out. Nobody laughed, Preston, at 10.23. They all think you can do it. Sounds good. All right, let's do the other way. If we're going to go the other way, instead of multiplying by 60, we will divide by 60. So we start, though, at the end this time, 52 seconds, okay? 52 seconds. Is that going to be more than 0.5 minutes or less than 0.5 minutes? More. 30 seconds would be 0.5 minutes. So we take that 52 and we divide it by 60. We said it was more than 0.5. It is. It's 0.86 repeating. So we have 36 degrees and 12.86 repeating seconds. Let's look at the piece we have to get rid of now. Now we got to get rid of this 12.86. What? This is minutes. So we got rid of the seconds. We made it to minutes. Yes. Yep, sure thing. 52 divided by 60. Oh, like here? We take seconds and we divide by 60. Now we're going to take the minutes and we're going to divide by 60. So we have 12.86 repeating minutes. 12.86. Do you think that that is less than a half a degree or more than half a degree? Less than half. Nope. So we're going to divide it by 60 and we get 0.2144. So that's 36 degrees. 36.214 repeating degrees. So we took it from this degree, minute, second piece and we put it in this decimal form piece. So multiply by 60, divide by 60. I want you guys to quick practice that on your own. We're only going to go through here today, this spot right here. So I want you to practice those two, and then this part goes real quick. So see if you can do, convert this one to minutes, seconds, degrees, minutes, seconds. Convert this one back into a decimal. Follow your examples above, see if you can do it. Go. In case you got stuck, 0.423 times 60. Oh, 0.423 times 60. 25.38, so 23 degrees, 25.38 minutes. I want to get rid of the 0.38, so I take 0.38 times 60, and I get 22.8. So it's 22.8 seconds, and we leave the decimal at that point because, like I said, I can time somebody running. And you know, if I time Bryn running the 200 meters, she can run 22.8 seconds. All right, 152, 45, 20. 20 seconds. How does that compare to 1 minute? It's 1/3 of a minute, right? So if you took 20 divided by 60, you get 0.33. So 152 degrees, 45.33 minutes. Or seconds, sorry, minutes. Now I take the 45.33 and divide that by 60. Well, 45 minutes is it's about 3/4 of an hour. So it'll be about 3/4. If you take it and divide it, 45.3 repeating, divided by 60, you can see that we get 0.75, so about 3/4. So 152.75 repeating degrees. So we went from degrees, minutes, seconds into decimal form. Not too bad? All right. Sketch each angle in standard position. Got two things to do left. Okay, these are some of the basics about angles that we've been learning today. Got an angle in standard position. Okay, an angle has two parts to it. It has the initial side. The initial side of an angle always starts on the x-axis. Then it has what we call the terminal side. The terminal side is where we end in its rotation. So for example, that would be approximately a 42-degree angle. We draw an arrow from the initial side to where we turned to the terminal side. So we move 42 degrees in that positive direction. What's different about the next one? Negative. So I go, yep, go the other way. Initial side is there. Do I go past the spot or do I end before the spot? Past the spot. Because that'll be negative 90. So we're going to go about negative 113 degrees. I just draw my arrow to show that I rotated in the negative direction. Because that negative rotation is different than what I drew in green, right? So that's why we show that. So we would understand the difference. 4 pi over 3. Is that degrees or radians? It's radians. About how many degrees is, exactly how many degrees is 4 pi over 3? Do you remember? 240. So that's going to be over here in the third quadrant. So that's my 4 pi over 3. Negative 4.6, is that degrees or radians? Radians, because it does not have a degree symbol. So if that's 0, and we go the opposite direction, then this would be negative 3.14. This would be negative 1.57. This would be negative 4.71. Remember, we came up with those values the other day. We divide 3.14 in half, we get 1.57. Add 1.57 3 times, we get 4.71. So if I go negative 4.6, which quadrant am I going to end up in? Second quadrant. Very good. I start my initial side right on the x-axis to the right side, and I head in that direction, and I end up right there. Very good. So sometimes you need to, instead of writing in terms of pi, you got to express it as a decimal to figure out where you're going. 420, what's different about that? Yeah, it's more than once around. How much more than once around is it? 60 more than once around. So I'm going to start here, and I'm going to go around once and 60 degrees more. So that's my angle. The only way that I know that I went 420 degrees is due to my little arrow circle thing that I drew. Okay? So that's what you have to draw. Any questions on those 5? Okay, then the last part, arc length. Okay, we won't do area of sector, but we'll do arc length. There is a formula for arc length, and I'll show you tomorrow how we derive it. Today I'm just going to give you the formula. S equals R theta. So if you want to know the length of an arc, just take the radius and multiply it by theta. But you have to put a little note here. You have to be working in radians. If you're working in degrees, then the formula doesn't work. Okay? We have a different formula if we're working in degrees. So theta is in radians. It says find the angle in radians that satisfies the conditions below. Suppose you have a circle where the radius is 7 and the arc length is equal to 3. So it wants us to know this theta value right there. What is the angle measurement in radians if you have a radius of 7 and if you have an arc length of 3? tell me, is that more than one radius or less than one radius? It's less than. So my radian measurement will be less than 1 radian. I didn't wrap a full radius around. I wrapped 3 units around. So you just set up your formula. S is the arc length. What is S equal to? 3. What's the radius? Times theta. I'm trying to solve for theta. Divide both sides by 7. And we do one more. Radius of 4. Arc length of 13. So that can be more than 1 radian or less than 1 radian? More than 1. This could be more than 2 or less than 2. More than 3 or less than 3. More than 4 or less than 4. Less. You can see that you have for sure 3 that fit in, because 3 would give you 12. So let's figure it out. S equals R theta. What is S? 13, radius is 4. So theta is equal to 13 over 4 radians, which is the same thing as 3.25. So you said more than 3, less than 4. You're correct. Your assignment today is pretty straightforward. 1 through 16 is simply converting degrees to radians, radians to degrees. We practiced many of them today. 41 through 45, those will be arc length problems just like we did. So it looks like a long assignment. It actually goes by pretty quick.